Algebra 1 skills number 25, arithmetic sequence relationships with linear functions. So we talked in previous videos about how these are very, very similar to each other. We're going to go into that with a little more depth here. So first, to compare the two, arithmetic sequence, here again is your formula for that, where a sub 1 is your first term, d is your common difference. Meanwhile, linear function, which at least in slope-intercept form, looks like this: y equals mx plus b. Sometimes you'll see f of x equals mx plus b. And actually, if you were given numbers here, where n was a variable but a sub 1 and d were numbers, you could simplify this down to make it look like sort of this structure. Okay, so there's definitely a similarity there. Both involve adding by the same number repeatedly. And this number is called the common difference with arithmetic sequences and the slope with linear functions. So again, there's that relationship there. Now, there are differences between the two. Namely, linear functions can be evaluated at any real number. So when we say a real number, that can be negatives, fractions, even square roots, and so forth. Arithmetic sequences are only evaluated at the counting or natural numbers: 1, 2, 3, 4, 5, etc. Okay, so that's a subtle difference between the two. But linear still means, despite the fact that it can be evaluated any real number, it still means for every change in x, you have a consistent change in y. Okay, so a lot of times you think of linear functions kind of as the x values going up by 1, even though you can evaluate them anywhere. So to look at that a little more closely, here's a linear function. You could say y equals 2x plus 3. We'll say f of x here. Just realize f of x is a function notation. And this shows some values evaluated there. So we took the red ones to show that they don't have to be counting numbers. You can put any numbers you want into that, and these all work. If you put 1 in where x is, 2 times 1 plus 3 is 5. If you put 1.5 in there, 2 times 1.5 is 3, 3 plus 3 is 6, and so forth. But linear functions, you can put anything you want. But for the arithmetic sequence, which actually has very much the same appearance, you only put in the counting numbers right here. You can't put 1.5 into that, because a sequence is a list of numbers that are defined by their positions. And you can't have a 1.5 position. You only have a 1, a 2, a 3, and so forth. If you were to graph that, the same examples, linear function, you fill in all the gaps. So not just 1, 2, 3, 4, but everything in between. Whereas for your arithmetic sequence, notice it's what we call discrete, only at the counting numbers. So you have, for example, 1. If you put 1 in there, you get 5, and that dot is represented there if you look closely, and so forth. Okay, so that's one of the subtle differences between the two. A couple examples. Write an arithmetic rule and a linear function for this representation. This is a little tabular representation where, again, we're only doing it for the whole numbers, but we know that if it were a linear function, you can actually go in between. So we're going to use the same, what we call the explicit formula. A sub 1 is 6. The common difference is -4. Remember, the common difference can be negative. And if you're not sure what it is, you just take any number in the sequence and subtract the previous one, okay? And remember, our actual values here are the ones on the bottom. These are just the counters, 1, 2, 3, 4. We're going to distribute that -4. -4 times n is -4n. -4 times -1 is +4. And then we're going to combine those like terms. So a sub n is equal to -4n plus 10. Meanwhile, the linear function would just be f of n, or again, you could say y, or you could say y and x if you wanted to. Here we just used n. F of n is equal to -4n plus 10. So they look just alike. Okay, but again, if it's understood to be linear, then you can put anything in for n. But if it's an arithmetic sequence, you can only put the counting numbers in. And another look at the first 4 terms of that sequence. Again, the linear function here could get in between those. But you see 6, 2, -2, -6. And what's interesting here is that if you look at the arithmetic sequence, you don't actually see a sub 1 in here. A sub 1 was right there, that's 6, but it combined with that 4. And what this 10 would be here, what we call the y-intercept for a linear function, would actually be kind of like the 0th term, which you can't have for an arithmetic sequence. We don't go back to 0, but the 6 doesn't actually show up in there if you go all the way and simplify it. But what does show up would be the one before the 6 if you're thinking in terms of arithmetic sequence. So just an interesting observation there. Let's take an example. The state-made study guide likes to ask questions like this, so we'll entertain it. If f of 7 is how you read this, equals 8 times 7 minus 6, what function gives f of x? Well, it's quite simple. You just recognize that for functions, which we'll discuss later, for functions, whatever you put in for x here, you also put in for x there. So you just simply change those 7s back to x's. So f of x equals 8x minus 6. Kind of a silly question, but it is just a way to gauge your understanding of what a function is. So a little bit more on linear versus arithmetic.